Yeah, students, good evening to all of you. Last class we discussed about two essay questions completed, and the next important short answers we discussed in the periodic classification. In the last class, essay questions are over, Nana, regarding periodic classification. Now in the today's class, we discussed about short answers of the 4 mark questions. Now see then, what is the first question regarding the short answers of the 4 marks? See the questions here. Give any 4 properties of transition elements. See, for 4 marks and 8 marks, you write as a point wise, easy to understood. See the first point. Actually, the transition elements are what? The transition elements are very hard metals. The first point, see, so the transition elements are what? Very hard metals. So these are the very hard metals with what? High melting point and high boiling points. With the melting points and boiling points are very high, because generally the metals are very hard nature, the melting points, boiling points are high. And see the second point, these transitional elements exhibit, second point, you write as a point wise, you get 4 marks, Nana. The transitional elements exhibit what? The transitional elements exhibit variable oxidation states. What I am saying, they exhibit what? Variable oxidation states. You ask a question, why sir the elements exhibit variable oxidation state? Because of the incompletely filled configuration of what? NS2, N-1, D1 to 10. Because of the incompletely filled configuration of the D subshell. What is the reason? Because of the incompletely filled configuration of the D subshell, they exhibit variable oxidation states. One of the best examples for that, manganese element belongs to the 3D series. The element can show the oxidation state of what? Manganese plus 2. It can show the oxidation state of maximum of what? Manganese plus 7 state. One of the best examples. That means it shows the manganese of the oxidation state of plus 2, plus 3, plus 4, plus 5, plus 6, up to the maximum of what? Plus 7, like that. Because of the incompletely filled N-1D, 1 to 10 configuration. This is the second point. And see the third property. Now, generally, the transition elements exhibit what? The transition elements exhibit different kinds of what? Exhibit different kinds of catalytic properties. Tell me what I am saying. They can exhibit different types of the catalytic properties. Yes, most of the transition elements are used as what? Catalytic properties, used as the catalyst in different kinds of the reactions. Say, for example, in the Haber synthesis of the ammonia, by Haber's process, iron is used as a catalyst, right? In the synthesis of the sulfuric acid by contact process, platinum is used as a catalyst. One of the best examples. In hydrogenation of the oils, nickel is used as a catalyst. In hydrogenation of oils, nickel is used as what? Catalyst. That is the third important point. And see the points once again. Transition elements are very hard metals. Because of the very hardness, they exhibit high melting points and high boiling points with high densities. Because the hardness is more, density is more, right? And the second point is what? The transition elements exhibit what? Variable oxidation state because of incompletely filled configuration. That is the second point. Come to third point. The transition elements exhibit different kinds of catalytic properties. Why they exhibit catalytic properties? Because of the variable oxidation state, they can show the catalytic properties. One of the best example of that. One of the best examples is iron is used as a catalyst in the synthesis of ammonia by Haber's process. Platinum used as a catalyst in the synthesis of the sulfuric acid. Nickel is used as a catalyst in hydrogenation of the oils. And see the next catalytic property of the transition elements. And the transition elements, they can form what? The transition metals, they can form interstitial compounds. The transition elements forms what compounds? Interstitial compounds. One of the nice point. They can form interstitial compounds. You ask a question, sir, what are interstitial compounds, sir? Simple logic. The transition metals have the BCC lattice or FCC lattice or simple cubic lattice, their whites are there. In that whites, non-metals are occupied. In that whites, non-metals are what? Occupied. That's why the transition metals forms what? Interstitial compounds because of different kinds of the whites. White means what? Empty space. In that empty space, the non-metal atoms like hydrogen, carbon, they are entered into that empty spaces. They are called interstitial compounds. And see the next point. Most of the transition elements, most of the transition metals, they can show good conductivity. Show what? Good conductivity. What is the meaning of good conductivity? Good conductivity means what? Help in the flow of the current. Good conductivity means what, students? Help in the flow of the current. Most of the transition metals are, they can show the good conductivity property. One of the best example, copper metal. One of the best example, silver metal and gold metal. So these are the 4 important properties of transition elements. But I am writing 6 points. Out of the 6 points, you write any 4 points for getting out the 4 marks. Very easy. Chemistry explanation of the IP is very easy. You know the minimum basics. Now the explanation is very easy, not so much difficult, right? And the next one. Electron affinity of the chlorine is more than what? Fluorine. Explain. This is the question. Electron affinity of the chlorine is more than that of the fluorine. Why? Simple logic. You know the configuration of the chlorine. Atomic number 17. For that, what you write? You write 1s2, 2s2, 2p6, 3s2, 3p5. Here 3d0 is there, right? Come to the fluorine. Atomic number 9. What you write? 1s2, 2s2, 2p5. Understood what I am saying? Now, in the second orbit, now see in the fluorine, in the second orbit, D subshell absent. Understand, students? Simple logic. D subshell is absent in the second orbit. But in the third orbit, D subshell is vacant. What is vacant? D subshell is vacant because D subshell is vacant when electron is added to this fluorine atom. What is electron affinity? Simple explanation, students. Electron affinity means what? When electron is added to this fluorine atom, now the electron enters into the vacant 3D subshell. When electron enters into the vacant 3D subshell, now the fluorine changes to what? Cl minus ion with loss of heat. With loss of what? Heat. Here more heat is liberated because 3D is vacant. When electron is added to the fluorine atom, forms what? The fluorine atom forms F minus, but heat is liberated. That heat liberated is less compared to the chlorine because here D subshell is absent. What is the reason? Here D subshell is absent in the fluorine. Understood? D subshell is what, Nana? Absent in the fluorine. But in the chlorine, D subshell is present. Because in the chlorine, D subshell is present. That's why more amount of heat is liberated in the chlorine. That's why, because of the vacant 3D subshell in the fluorine atom of atomic number 17, electron is added, more amount of heat is liberated. Here 3D D subshell is absent in the fluorine. Electron is added, forms F minus, but less amount of heat is liberated. This is the simple explanation regarding electron affinity. Now this electron affinity also called what? Electron affinity also called electron gain enthalpy. Also called what, students? Electron gain enthalpy. Right, students? Yes, Nana. Understand? Yes, Narendra. What is your doubt, Narendra? Amphoteric oxide. Amphoteric means what? It can show both acidic property as well as basic property. One of the best example, zinc oxide, cadmium oxide, tin oxide, lead oxide, examples of amphoteric oxides. They can show both acidic nature as well as basic nature. Understood? That is called amphoteric oxide. So this is the simple explanation of online students. It's very easy explanation, students, right? See the next question. This is one of the beautiful question. See, what is lanthanoid contraction? What are the consequences of the lanthanoid contraction? Simple explanation. First of all, what are lanthanoids? From atomic number 58 to 71, they are called lanthanoids. Yes or no? So, atomic number 58 means what? Cerium. Atomic number 71 means what? Lutetium. Yes, clear. Now what I am saying, exactly from cerium to what? From cerium to lutetium, atomic size gradually decreases. One other point I said, atomic size gradually what happens? Atomic size gradually decreases from cerium to lutetium. You asked a point. Why is the atomic size gradually decrease from cerium to lutetium? Means because in the lanthanoids, the last electron. What is the meaning of last electron? Last electron nothing but what? Differentiating electron. Differentiating electron means what? Differentiating electron means last electron. The last electron enters into what? The last electron enters to 4f subshell. Tell me what am I said, students? The last electron enters to the 4f subshell. As you are very well known, the 4f subshell is what? The 4f subshell itself is a diffuse shape. What is the meaning of diffuse? Diffuse shape means what? Big size. Because of the diffuse shape of 4f subshell, because of what? Diffuse shape of what? 4f subshell. The 4f subshell offers a pool shielding effect to the nuclear force because of the diffuse shape. Diffuse means what, Nana? Big size. Because of the big size of 4f subshell, the 4f subshell offers a pool shielding effect. Because it offers a pool shielding effect, the nuclear force increases from left hand side to right hand side. The nuclear force increases on the valence shell. As nuclear force increases on the valence shell, now atomic size gradually decreases because 4f subshell offers the what? Pool shielding effect or weak shielding effect. That is called what? That is called lanthanoid contraction. Repeat the statement once again, students. What is lanthanoid contraction? So from cerium to lutetium, atomic size of lanthanoids gradually decreases. Why they gradually decreases? Because of the last electron enters into the diffuse shape of the 4f subshell. The diffuse shape of 4f subshell offers the weakest shielding effect. Because it offers the weakest shielding effect, so the nuclear force and the valence shell is more from cerium to lutetium. By that, atomic size decreases. That is called lanthanoid contraction. Now go to the consequences. Consequences also very important. Now see the first consequence. So you are very well known. You know these black elements. This is 3b. This is 4b. This is 5th b, and this is 6th b, 7th b, like that. 1b, 2b. This is the D block element group. 10 groups are there. Yes or no? This is 3rd group, 4th group, 5th group, 6th group, 7, 8, 9, 10, 11, 12, like that. Now this is what? 4th period, right? This is 5th period, right? This is 6th period. Yes. Now after 3b, so this is what, Nana? Here actually in the 6th period, what is there? Lanthanum is there. Lanthanum atomic number 57. After 57, so this is the position of what? This is the position of lanthanides from 58 to 71. From 58 to 71, this is the actual position of the lanthanides. What is the actual position of lanthanides? The actual position of lanthanides are 3rd B group. Students, one of the beautiful objective be. One of the beautiful objective be the position of the lanthanides is 3rd B group. But there is no place in the 3rd B, keep at the bottom of the table. There is no place in the what? 3rd B, keep at the bottom of the table. Very good. Now after lanthanum, from cerium, here, what is there? Here hafnium is there. 58 to 71 completed na? 58 to 71 completed, you get what here? Hafnium. Hafnium 72, and this is what? So 72 mercury, here mercury is 80. Now from here what is there? Here scandium, here zinc is there, here yttrium, zirconium is there. What is there? Zirconium is there, like that. Now see, this is the one of the important point. This is called in the 4th period 3D series is there, 4D series is there, 5D series is there. Now the consequences starts. Students, now what I am saying, consequences start. See the first consequence. Atomic radius and ionic radius. What I am saying, atomic radius and ionic radius of 4D and 5D series of elements. Atomic and ionic radius of 4D, 5D series of elements similar. Why atomic radius of the 4D, 5D series of elements are similar? Because of the Lagrange interaction. Atomic radius and the ionic radius of the 4D, 5D series of elements are similar from what I am saying, from 4th B group to, from 4th B group to 2B group. Because of what? Due to lanthanoid contraction. This is the first consequence. Simple logic. So from 4B2 up to what? Up to 2B. Here what is there? Zinc cadmium. So the atomic radius and ionic radius is similar. Best example, zirconium atomic radius is equal to what? Hafnium atomic radius. Simple logic. Atomic radius of the cadmium is equal to atomic radius of what? Mercury, like that. From 4th B to what? From 4th B to 2B. That is the first consequence. And see the second consequence. The second consequence also very important. Now, regarding the second consequence, see, so the nuclear force acting, what I am saying, the nuclear force acting, one of the second point is nice point, Nana. Also important for objective. Also important for what? Objective. The nuclear force acting on the 5D series of elements, nuclear force acting on the 5D series of elements, 32 times heavier than 4D series of elements. Simple logic. The nuclear force acting on the 5D series of elements 32 times heavier than 4D series of what? 4D series of the elements. Is 32 times is heavier. Is the second consequence. Because of what? Due to Lagrange contraction. LC means what, Nana? Lagrange contraction. Understand what I am saying? And see the third consequence. The third consequence is very, very important consequence. See, the third consequence is very important. From cerium to lutetium, what I am saying, from cerium to lutetium, atomic size gradually decreases or increases. Atomic size gradually decreases. That's why, so from cerium to lutetium, due to Lagrange contraction, basic nature of the metal decreases. What I am saying, basic nature of the metal decreases. Why basic nature of metal decreases? Because atomic size decreases. Therefore, basic nature of the metal decreases and acidic nature of the metal increases. What I am saying, acidic nature of the metal increases. That is the simple point. That is the third consequence. You write the consequences like that. Generally, lantanides are metals. In the metals, generally basic nature increases. From left to right here, basic nature decreases. Why? Because atomic size decreases. That's why basic nature of metals, what happens, students? Basic nature of the metals decreases. Understood what I am saying? Very good. This is the consequences of Lagrange interaction. Simple. And the next one, explain electronegativity and electron affinity. Simple statement. So first of all, how you define electronegativity value? See, electronegativity value is defined as, for example, you take a bonded molecule. HF is a bonded molecule. En value of the hydrogen 2.1, En value of the fluorine is 4.0. Now, how you define electronegativity? So the attraction of, I am saying, attraction of the bonded paired electrons. What I am saying, attraction of the bonded paired electrons towards one of the bonded atom itself. One of the bonded atom itself is known as what? Is known as electronegativity. See here, repeat the statement once again, students. What is electronegativity? Attraction of the bonded paired electrons towards one of the bonded atom itself. That means fluorine En value is more. Now the bonded electrons are attracted towards the what side? Fluorine side. Now the fluorine get negative charge and hydrogen get positive charge. That is the meaning of electronegativity value. Understood, Nana? Yes, Aryan. Yes, Aryan. Very good, Nana. Aryan, very good. Nice. How much marks you got, Nana? Aryan, how much you got? How many marks you got, Aryan? MLR, IT, CS, Computer Science. Very good, Nana. How much marks you got, Aryan? Please tell me. In chemistry. Well, I know you are a shorter student. 67. Okay, for 67, how much rank you got, Aryan? For Aryan 67, how much rank you got? General information, Nana. Yes, I think so. You are a shorter student. Yes, I know very well. Very good, Nana. Anyhow, congratulations to you, Nana. Aryan. Nice, very good. No, I am fine. 18K. Nice, nice. Very good, brother. Now see. In chemistry, how many marks you got for short term? You join in Rules Academy is the best institute now. Yes. Now, here the attraction of bonded pair of electrons towards the one of the bond atom itself is called electronegativity. And take the next example. Second one is what, Nana? Electron affinity. So, simple explanation. What is electron affinity? Electron added to, see, electron added to isolated gaseous atom. Tell me, electron added. Oh, Aryan, very good, Nana. In chemistry, you got 28 marks. Very good. Yes, yes. Electron added to isolated gaseous atom. Amount of energy, amount of heat energy liberated. Amount of what? Amount of heat energy liberated. That is the meaning of what? That is the meaning of electron affinity. Repeat the statement once again. Electron added to isolated gaseous atom, amount of heat energy liberated is called electron affinity. In majority of cases, so electron affinity is what? Exothermic nature. Because amount of heat is liberated in the students. That's what this is what? Exothermic nature. One of the best example you taken, say, fluorine atom in the gaseous state. To this fluorine atom in the gaseous state, when electron is added, yeah, MD Jain. Yeah, good evening, MD Jain. Electron is added to the isolated fluorine atom in the gaseous state. You get what? Cl minus ion with liberation of energy nearly 348 kilojoules per mole. This much of energy liberated. That is the meaning of what? Electron affinity. This is the 2 marks question. So this is for 2 marks and this is for 2 marks. 2 plus 2, you get a 4 marks question. Yes, Nana? Yes. And see the next question. Write a short note on atomic radius, metallic radius, covalent radius. So this is the 4 marks question. First bit, second bit, third bit, like that. So what is atomic radius? Simple explanation. Atomic radius means you take a isolated gaseous atom. The distance between CE, the distance between nucleus. Tell me what I am saying. The distance between nucleus to the outermost orbit. This is called what? Valency shell. The distance between the nucleus to the outermost orbit of the valency shell is known as what? Atomic radius. This atomic radius is measured in picometers, measured in angstroms, measured in nanometers. Yes, 1 picometer is 10 power minus 12 meters. 1 angstrom is equal to 10 power minus 10 meters. 1 nanometer is equal to 10 power minus 9 meters. Repeat the statement once again. Atomic radius means what? The distance between nucleus to the outermost valence shell is called atomic radius. Come to the metallic radius. See, we take the best example. So the metal atoms. We take a metal solid. Metal solid composed of what? Metal atoms like that. The metal atoms are available adjacent like that. Now this is the nucleus, 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 nucleus. Now how you define? So half of the internuclear distance between, what I am saying, half of the internuclear distance. Simple explanation, no confusion. Half of the internuclear distance between adjacent metal atoms of what I am saying, students. Half of the internuclear distance between adjacent metal atoms. Adjacent metal atoms. Yes, Narendra. Diagonal relationship comes as next question, Anna. Yes, Narendra, that comes the next question. Half of the internuclear distance between adjacent metal atoms of given crystal of what? Given crystal. That is the meaning of what? Metallic radius. And see the next one. So what is the meaning of the covalent radius? Covalent radius means what? This is a covalent bonded molecule. Tell me what molecule? Covalent bonded molecule is the nucleus of the first atom, nucleus of the second atom. What I am saying, nucleus of the first atom and nucleus of the second atom. So this is called what? Nothing but a bond length. Is the bond length of the covalent molecule. What I am saying, bond length of the covalent molecule. Now, how you define the covalent radius? Okay, right. Now, how you define this covalent radius? Simple logic I said here regarding covalent radius. Half of the bond length of the given covalent molecule. What I am saying, half of the bond length. Half of the bond length of given covalent molecule. What I am saying, half of the bond length of the given covalent molecule is known as what? Covalent radius. Again, the covalent radius also measured in picometers, angstroms, nanometers, like that. Simple statement, Nana. Simple question. Yes. Now, completion of this, Narendra, completion of this question, you go to the diagonal relationship. Last question comes as that, as the fourth most important question. See, give the outer orbital general configuration of what? Noble gases. For noble gases, what is the general configuration? NH2, NP6 is completed. For representative elements, so NH1, 2, NH2, NP5. This is the general configuration of representative elements. Come to the transition elements. Now, regarding transition elements, what you write? NH2, N-1, D1 to 10. What I am saying? NH2, N-1, D, 1 to 10. For inner transition elements, what you write? NH2, N-1, D, 0 R1, N-2, F, 1 to 40. This is the general configuration of the noble gases. This is what? General configuration of the noble gases and general configuration of representative elements, general configuration of the transition elements, and general configuration of what? Inner transition elements like this. Each one bit has 1 mark. Totally, it's a 4 marks question, students. Each question carries 1 mark, 1 mark, 1 mark, 1 mark. You got 4 marks. And the next one. So, ionization energy one of the sodium less than that of magnesium, but IE2 of the Na higher than that of magnesium. Explain. Simple logic. See, first of all, you take the sodium. Sodium atomic number is what? 11. 11 means what you write? Neon has 10, 3s1. What is ionization energy 1? Removal of the first electron. When first electron is removed, what I am saying, when first electron is removed, forms Na plus ion. Na plus ion stabilized by neon configuration. Yes or no? That's why ionization energy 1 of the sodium less than magnesium. Yes, that's correct. But ionization energy 2 of the sodium is higher than magnesium. Yes. From Na plus, the ionization energy 2 is very high. Why? From Na plus, ionization energy is very high. Simple logic. Very, very high. Simple logic, because Na plus is stabilized by noble gas configuration. Simple statement. What I am saying? Na plus is stabilized by which configuration? Na plus is stabilized by noble gas configuration. Therefore, ionization energy 2 is very difficult. What I am saying, students? Ionization energy 2 is very difficult because Na plus is stabilized by neon configuration. That's why. So, the ionization energy 2 of Na plus should be greater than that of ionization energy of what? Magnesium. Simple logic. Because Na plus is stabilized by neon configuration. Tell me what I am saying. Na plus is stabilized by neon configuration. Simple logic, no confusion. Understand, students? Yes, very good. Now see, the next important point, which element of the third period has the highest ionization energy 1? Explain the variation of ionization energy 1 in this period. First you go for third period of elements. Yes, Nana? So what are the third period of elements? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. So this is the third period of elements. Now see the question carefully. So in third period of elements, which element has the highest ionization energy? Highest ionization energy 1. Yes. Chlorine has the highest ionization energy 1. You ask the question, why sir chlorine has the highest? Because left to right, what happens? I said this point in the last class also. Because left to right atomic size decreases. What I am saying, left to right atomic size decreases. Therefore, atomic size decreases, nuclear force is more on the valence shell. Nuclear force is what? Nuclear force more on the valence shell. As nuclear force more on the valence shell, that's why the chlorine has the highest ionization energy 1. And see the variation of ionization energy 1 in this period. That is also a very important point. Now understood why the chlorine has the highest ionization energy 1? Because of the small size. Nuclear force is more on the valence shell of the chlorine, because left to right atomic size decreases, nuclear force increases, therefore it has the highest ionization energy 1. Yes, students? Yes. Narendra, that answer comes later, Nana. Completion of this, that answer comes. Don't worry. Now, the variation of what? The variation of ionization energy 1. The variation depends on the configuration. Atomic number 11, atomic number 12, 13, 14, 15, 16, and 17. For that, what you write here? Neon 3s1. This is what? Neon 3s2, neon 3s2, 3p1, neon 3s2, 3p2, neon 3s2, 3p3, neon 3s2, 3p4, neon 3s2, 3p5. Now, what is the important point here, students? See, if the configuration is completely filled, if the configuration is exactly half filled, that is the stable configuration. That's why to remove the electron from the completely filled configuration, from exactly half filled configuration, more amount of ionization energy required. More amount of what? Ionization energy is required. Therefore, so the ionization energy 1 sequence, ionization energy 1 sequence, sodium has less ionization energy 1 compared to magnesium, but magnesium is more compared to the aluminum, because magnesium is a completely filled configuration. Aluminum is less than silicon. Silicon is less than what? Phosphorus. But phosphorus is more than sulfur. Why phosphorus is more than sulfur? Because phosphorus is exactly half filled. Because configuration is exactly half filled, this is the very stable configuration. Now, sulfur is less than chlorine. That is the reason. That's why this is the variation of what? Ionization energy 1 in this period. Because here, even though atomic size of the aluminum is less than magnesium, but ionization energy more for magnesium because of completely filled configuration. Even though atomic size of sulfur is less than phosphorus, but phosphorus ionization energy is more because of the half filled configuration. More ionization energy is required. Simple logic. Understood? Yes. Yes. Now, Narendra, see this question. This is the last question, Nana. See this question. What is diagonal relationship? Simple logic. I am explaining with the example, Nana. Give a pair of elements, they showing diagonal relationship. Why do they show this relationship? Yes. You take the example. For example, take lithium, beryllium, boron, carbon. So this is what? 1A group, 2A group, 3A group, and 4A group. Right, Narendra? And take the examples here. So this is second period of elements. And come to the third period of elements. Sodium, magnesium, aluminium, and not you write here silicon, you write like this. What is diagonal relationship? Diagonal means what? Across. Across, lithium can show the similar properties with respect to magnesium. Beryllium can show the similar properties with respect to aluminium. Boron can show the similar properties with respect to what? Silicon. That is the meaning of diagonal relationship. That means what I said, the relationship, like the statement is very important. The relationship in which the pair of elements, the pair of elements, the relationship in which the pair of elements exhibit, the pair of the elements exhibit similar physical and chemical properties. The pair of elements which exhibit similar properties. You ask the question, Narendra, why they show similar properties? Due to similar polarizing power. Due to what? Due to similar polarizing power. What is the meaning of polarizing power? Charge by size ratio. What is polarizing power, Nana? Narendra? Charge by size ratio. The charge by size ratio value is similar. Lithium with magnesium, beryllium with aluminum, boron with silicon. That is the meaning of what? Diagonal relationship. That pair is called what? Diagonal related pair. Similar polarizing power means what? Charge by size ratio. Here similar polarizing power also nothing but ionic potential. Tell me, also nothing but what? Ionic potential. Similar polarizing power nothing but what? Also called ionic potential. Understood, Narendra? Yes, very good. And this is the one of the important essay question left in the periodic classification. So what is the important essay question left in the periodic classification? Write an essay on SPDF block elements. Simple logical question, Narendra. See, first of all, see the essay on S block elements. Now regarding S block elements, simple statements. S block elements includes 1A group and 2A group. For 1A group, the general configuration is NS1. For 2A group, the general configuration is NS2, right? And generally, these S block elements are very soft metals. What I am saying, soft metals and soapy to touch. Tell me what I have said. Soapy to touch. There's very soft metals, and the soft metals are very soapy to touch. Okay, and these metals, the elements are exist in the what? Metallic state. The metals violently react with water. Explosively react. Violently means what? Violently means explosively react with water. Explosively react with water with the liberation of H2 gas. With liberation of what, students? With liberation of H2 gas, this is an exothermic nature. What is the meaning of exothermic nature? Amount of heat is liberated out. Now, down the group, in S block elements, down the group, reducing nature of the metals increases. What I am saying? Reducing nature of the metals. What is the meaning of reducing nature of metals? Electron losing ability. What I am saying? Electron losing ability increases. That is the meaning of reducing nature. One of the excellent beautiful point. So these are the properties of S block elements. Repeat the point once again. So the S block elements are what? S block elements are reducing nature of metals. What is the meaning of reduced nature, Nana? So electron losing ability increases. Therefore, the S block elements acts as best reducing agents. That means best reductants which are easily oxidized. What I am saying? Best reducing agents are easily oxidized. And because of the softness, so the melting points and boiling points are low. What I am saying, students? The melting points and boiling points are low. Why the melting and boiling points are low? Because of the softness. So properties of S block elements are over. In the S block elements have no non-metals and no metalloids. Only so the metals are there. And come to the P block elements. Come to what, students? P block elements. Actually, now regarding the P block elements. The P block elements are composed of what? The P block elements are composed of 30A group. What I am saying? From 30A group to 8th A group or 8th group. That means, so 30A group means what? Boron family included, carbon family included, nitrogen family included, oxygen family included, fluorine family included, noble gases are included in the P block elements. That's why, so in P block elements, all kinds of elements are available. What is the meaning of all kinds of elements? In the P block elements, metals are available. Tell me what I am saying. Metals are available and non-metals are available and amphoteric metals are available. What is the meaning of amphoteric metal as well as non-metal? Amphoteric metals are available in the P block elements. And in the P block elements, solid state of the metals are available, liquid state of the metals are available, and gaseous state of the metals are available. And in the P block elements, across the period, what I am saying, students, in P block elements, across the period, what happens? Atomic size, atomic radius decreases. As atomic radius decreases, non-metallic nature increases. What I am saying, non-metallic nature increases. Mostly students, Harika, mostly classify the modern period table. Generally not classified to Harika. Across the period, atomic radius decreases, non-metallic property increases, right? Non-metallic property, what happens? Increases across the period. Now, in the P block elements, Harika, across the group, what I am saying, across the group, atomic radius increases. Atomic radius increases. So what happens? Metallic property increases. Tell me, student, metallic property increases across the group. So these are the properties of what? P block elements. Simple logic. In the P block elements, what groups are there? 30A, 40A, 50A, 60A, 70A, noble gases means 8 group. 8 group also called what? 0 group. 8 group also called what? 0 group. 3rd A means what? Boron family. 4th A means carbon family. 5th A means nitrogen family. 6th A means oxygen family. 7th A means fluorine family. And 8th A means noble gases. 0 groups are there. So P block elements are composed of what? Metals. Tell me. Metals, non-metals, and amphoteric metals. So the state of the matter of the element: solid state, liquid state, gaseous state. Across the period, atomic radius decreases, non-metallic property increases. Across the group, atomic radius increases and metallic property also increases. One of the important properties regarding P block elements. And in the P block elements, generally the metals are somewhat hard nature. Metals are somewhat hard nature. Because as atomic number increases, hardness of the metals are increases. These are the properties of P block element. Already in the 4 marks question, I said properties of P block elements. In the 4 mark short answer, I said the properties of our students. I said the properties of the P block elements. That is already over. And come to the properties of A block elements. Now come to the properties of the A block elements. Actually, students, regarding the A block elements, actually A block elements are mainly classified into 2 series. One is called what? 4F series, and next one is called what? 5F series. What I am saying, Nana? 4F series or 5F series? Yes, Harika. You go to that YouTube channel, Roots Academy YouTube channel, subscribe, Nana. You get the free videos. Yesterday and day after day, 2 videos completed, Harika. Yesterday and day after day, we started free online classes for IPE. And you subscribe you go to the YouTube and subscribe Roots Academy channel, and you get the free videos. It's the best objective coaching academy. For the benefit of the students, we give the free video of this IPE classes to make the much more marks to the students. Right? Yes. A block elements. Regarding A block elements, 2 series are there, students. 4F series and next one is what? Next one is what? 5F series. Actually, the 4F series of elements are known as what? The 4F series of elements are known as lantanoids, right? And the 5F series of elements are known as what? Actinoids. Tell me the name? Actinoids. And these lantanoids are also called what? Rare earth elements. Lantanoids are known as what? Rare earth elements. And these actinoids are also called what? Man-made elements. Man-made means what? Man-made or synthetic element. Tell me what elements? Synthetic elements. In this way, the A block elements are classified into 4F and 5F series of elements. Right, Nana? And important point. And most of the A block elements are what? Most of the A block elements are metals. And these metals are what nature? Radioactive nature. Most of the block elements are radioactive nature, especially in the 5F. Especially in the 5F, after atomic number 92, most of the elements are radioactive nature. And these metals are silvery shiny metals. Silvery shiny metals. That means they give the luster appearance. Silvery shiny metals. Yes. And these react with what? Non-metals and react with acids and bases. So these are the properties of what? A-block elements. And here A-block elements are kept in what? Actually the 4F block element, you write as a points, kept in the third B group, where is placing third B group and sixth period, that is for the A-block 4F. And come to the 5F, 5F is kept in the third B group. Group is same but placing in the seventh period. Yes or no? So this is the location of the A-block elements. You can write the points like this and you get full marks, 8 marks out of 8. 8 marks, 8 of 8. Yes? Yes, Nana? Narendra, is the remembering of the elements in the periodic table is somewhat difficult. That is comes in the objective, Nana. For IPE, you said for remembering that is not useful for IPE. That questions are not asking. For objective, by using noble gas atomic number is very easy to remember, right? Narendra? Yes, Nana. And C. And we come to the chemical bonding. Successfully 2 topics completed. The first topic, atomic structure, is over. The second topic, periodic classification, is over. And we are successfully entered to what? Third topic, simple logic. You want to go for the free videos of the Roots Academy for IPE classes, and you enter to the YouTube and the Roots Academy, please subscribe it. Now, easy to access the free videos of this IPE classes. But it's not for IPE. The academy not meant for IPE students. The academy is the best objective coaching for IIT Advance and mains and NEET examination. But the TS board announces that examination of October 25th for the benefit of the students, we give the classes, free classes to get good marks. Yes, ma'am. Now see, what is understand by the hybridization? Explain different types of hybridization involving S, P orbitals. Yes, Nana. So chemical bonding weight is, Nana, 8 marks question and maybe 4 marks or 2 marks. Definitely one 8 marks question you come across, and maybe 4 marks or 2 marks questions are given. That is the weightage, Nana. Right, Nitish? Yeah. See, concept of what? Hybridization. Simple statement I said. Simple statement. You know, in the valence shell, atomic orbitals are there. Simple logic. In valence shell, what are there? Atomic orbitals are there. See the statement. The phenomenon in which atomic orbitals of similar energy. Atomic orbitals of what? Similar energy. The phenomenon in which atomic orbitals of similar energy combined themselves forms equal number of hybrid orbitals with similar shape and energy. That is the statement of what? Equal number of hybrid orbitals with a similar shape and energy. That is the meaning of what? Hybridization. Simple statement, repeat once again. You take the configuration of element in the valence shell, atomic orbitals are there. Yes or no? See, simple example, take the example of the carbon. Carbon atomic number is 6. What you write? Helium in the first exit state, 2s1, 2px1, 2py1, 2pz1. In the first exit state of the carbon, right, students? Now in the valence shell, s orbital, px, py, pz. So s, px, py, pz, they are available in the same valence shell of the two. The process of intermixing of the atomic orbitals. Tell me what I am saying. The process of the intermixing of the atomic orbitals in the valence shell combined equal number of hybrid orbitals. Combined produce what? Equal number of the hybrid orbitals of sp3. You get 4 sp3 hybrid orbitals. One s, one px, one py, one pz. 1 plus 3 what? You get equal number of the 4 sp3 hybrid orbitals. You get with a similar shape and energy. Similar shape means what? Hybrid orbitals are dumbbell shape. Tell me what shape, Nana? Dumbbell shape. For example, sp3 hybrid orbitals. The shape is what? Dumbbell, like this. sp3 with dumbbell, sp3 with dumbbell, and sp3 with dumbbell. One lobe is larger, one lobe is smaller, like this. This is sp3, 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 like that. This is the explanation of what? Tell me, explanation of statement of what? Hybridization. Explain the different types of hybridization involving S gamma p orbitals. Yes, first we discuss about what? sp3 hybridization. Arey Nana, simple explanation, brother. Listen carefully. Listen carefully. Simple explanation. sp3 hybridization. One of the best example with sp3 hybridization. Take the example of the methane gas formation. Yes, carbon atomic number is what? 6. For 6, what you write? Helium, 2s1, 2px1, 2py1, 2pz1 in the first exit state. Yes or no? 2px1, 2py1, 2pz1 in the first exit state. Now, what happens? One s orbital, simple. Yeah, you take the water also, no problem. Water or methane or ammonia also. Nitish, ammonia also, no problem, Nitish. So, one s orbital in the valence station, 3 p orbitals are combined themselves and forms what? 4 sp3 hybrid orbitals with what? With single electron each. With what? Single electron each. Not wasting on that. Now this is what? sp3, first sp3, this is second sp3, this is third sp3, and this is fourth sp3, like that, having single electron, single, and sp3 have the dumbbell shape, and they have head-on overlapping. The hybrid orbitals are what, students? The hybrid orbitals are head-on overlapping with the surrounding atom. This is a hydrogen spherical, 1s1. Hydrogen spherical, 1s1. Hydrogen spherical, 1s1. Hydrogen spherical, 1s1, like that. You get 2 electrons like this, 2 electrons like that, and you get a methane gas. This is the sp3 hybridization explanation. Come to the explanation of the sp2 hybridization. Explanation of what? sp2 hybridization. Regarding the sp2 hybridization, take the example of the BF3 molecule formation. Tell me what molecule formation? BF3, boron trifluoride. Yes, simple explanation we start. Boron. What is the atomic number of boron? 5. What you write, students? Helium. I am writing in the first excited state. Where I am writing? First excited state. Yes, Nana. 2s1, 2px1, 2py1, 2pz0. In BF3, 2pz is vacant. Now, in the surrounding 3 fluorine atoms are there. That's why one s orbital in the valence station, 1 px, 1 py combined themselves gives rise to what? 3 sp2 hybrid orbitals with single electron each. What I am saying? Single electron each. Yes or no? Yes. Now, see, this is what, student? This is what? sp2 with the single electron, and this is what? sp2 with the single electron, and this is what? sp2 with the single electron. So this is sp2 with single electron, sp2 with single electron, because all hybrids are dumbbell shaped. One lobe is larger, one lobe is smaller. Yes or no? And combines with what? Surrounding fluorine atoms. In the fluorine, 2pz have the single electron, head-on overlapping with 2pz of the fluorine, head-on overlapping with what? 2pz of the fluorine, head-on overlapping with what? Head-on overlapping with 2pz of the fluorine, like that. This is F is the formation of BF3. Formation of what? BF3 here. The bond angle is what? The bond angle for BF3 is 120, and this is planar geometry, students. What geometry, students? Planar geometry. sp2 explanation completed. Nitish, understood? Nitish, please tell me. Nitish, understood what I am saying? Yeah, it's very easy, brother. And take the explanation of what? SP hybridization. Tell me, explanation of what, students? SP hybridization. Now, regarding the SP hybridization, we take the explanation of beryllium dichloride molecule. Tell me, explanation of what, students? Beryllium dichloride molecule. Yes. Very good, Nitish. Nice explanation. Yes. Beryllium atomic number is 4. Helium 2s1, 2px1. This is in the what? In first exit state. What I am saying, students? In first exit state I am writing. So 2py as mt0, 2pz as fd0. Now, what is the simple logic here? The simple logic here in the valence shell, S comma P atomic orbitals are combined themselves. What I am saying? S comma P atomic orbitals are what? Combine themselves and get what? 2 sp hybrid orbitals with single electron each. What I am saying? With a single electron each. Yes or no? Now this is the one of the sp3 with the single electron, and this is the second sp3. This is the second sp3 with a single electron. Understood? Now this is one of the sp3 with single. This is the one of the sp with single. Now chlorine. In the chlorine, 2pz have a single electron. In the surrounding atom of the chlorine, 2pz have a single electron. Hybrid orbitals are what? Always head-on overlapping. Therefore, the 2pz atomic orbital of the chlorine having single electron head-on overlapping. The 2pz atomic orbital of the chlorine with the single electron head-on overlapping with this sp hybrid orbital forms a sigma bond, forms a sigma bond. This is the explanation of what? Sp hybridization is the one of the beautiful essay question. One of the excellent essay question for the IPE class. One of the beautiful essay question. Understood what I am saying? Nitish, please tell me understood. Nitish, Narendra, Harika. Yes. The shape is what? It's a strike line. Strike line means what? Not calling as shape, Nana. Nitish, not calling as a shape. It is calling as a linear geometry. Linear geometry and bond angle is 180. What is the bond angle here? 180. Don't call as shape. And central atom lone pair is there. Central atom lone pair is there is calling as a shape. And central atom have no lone pair is calling as a geometry. Bond angle is 180. Explanation is over. And one of the excellent bit now start. One of the excellent bit start. Give an account of what? VSC PR theory. Without this question, have no exam paper. A damn surely given. For example, this question not given come to the exam, definitely is the one of the objective theory question is given. One of the objective theory question given. What is VSC PR theory? Valence shell, electron pair, repulsion theory. What am I saying, students? Valence shell, electron pair, repulsion theory. Now, give the explanation. For example, take the explanation of the methane gas. Explanation of the ammonia. First example start. First point on applications. First point I said methane, ammonia, H2O. In the methane is a tetrahedral with sp3. Understood? And second one is what? Ammonia is what? sp3 with a lone pair. Understood? And next one, H2O having two lone pairs with the two hydrogens. Now see the excellent point. All belongs to what? All are belongs to sp3 hybridization. That means, what is the important point now is said? On central atom, as number of lone pair changes. Here the bond angle is first application 109 degrees. Here the bond angle is 107 degrees. Here the bond angle is 104 degrees. That means what I am saying on the central atom, students. See, first application, if the molecules have similar hybridization, students, what I am saying, if the molecules have what? Similar hybridization of sp3 on central atom, what I am saying, on central atom, as number of lone pairs increases, as number of lone pairs increases, the bond angle in the molecule decreases. Bond angle in the molecule. Bond angle in the molecule decreases. Understand the point what I am saying? Repeat the one of the extent point is the first application of BSCPR theory. Repeat once again. If the molecules are belongs to similar hybridation, you write the statement like that. And central atom as number of lone pairs increases, bond angle in the molecule decreases. The first application successfully completed. And come to the second application. Come to what, students? Second application. Say for example, regarding second application, take the example of H2O molecule. Take the example of the OF2 molecule. Now see, what is the point here is the two lone pairs on the central atom. Here also two lone pairs oxygen on the central atom. Here the hybridation is what? sp3. Here hybridation is sp3. Yes or no? This shape is what? V shape of the molecule. And this shape is what? Again V shape of the molecule. Now see, in the given molecule, what I am saying, in the given molecule, En value of the surrounded atom. What I am saying, En value of surrounded atom more than En value of the surrounded atom more than central atom, more than central atom. Yes, very good, Nana. Nitish, very good. En value of surrounded atom more than En value more than central atom. En value, very good, Nitish. Central atom En value, then lone pairs occupies more space. Then what I am saying, lone pair occupies more space. Very good, it is. As lone pair occupies more space, bond angle, what happens? Bond angle slightly decreases. Bond angle slightly, what happens? Decreases. Because here, En value of the fluorine is what? En value of fluorine 4.0, this is 4.0. This is 3.5. Here En value is 3.5, here En value is 2.1, 2.1. Therefore, as En value of the surrounding atom is more, the bond is shifted fluorine side. Okay, here the bond is shifted to what side? Oxygen side. That's why. So the bond angle of H2O, what I am saying, the bond angle of H2O is greater than the bond angle of what? The bond angle of the OF. The bond angle of H2O generally here 104 degrees 5 minutes. And the bond angle is 102 degrees 5 minutes. Because the bond pair shifted to fluorine side, lone pair occupies the most space. This is the second application. And remaining applications see in the tomorrow class, right? And remaining applications we see in what, Nana? In tomorrow class. Clear up to here? Nitish, MD Jain, Nana, MD Jain, Nitish, clear up to here? Have any doubts? Please tell me. And tomorrow continue this class. Tomorrow on the same time. So 8 to 9. Yes? Clear what I am saying? Please tell me, respond. Yes, Nitish, very good. It's the best academy, Nana. It's the one of the best academy near to the JNU to learn the objective classes of IIT Advance, IIT Mains, and followed by NEET, Nana. So, for the sake of the benefit of the students, we give the online classes because October 25th exams are there, na? For that purpose only. But it's not for IPE classes. Institute is best one for objective courses. And you check in the YouTube, Nana. You check the Google Rules Academy. Is the best acceptance is there. So best reviews are there regarding this object institute, Nana. Right. Tomorrow we continue on the same topic.